Welcome to the world of perimeter area problems, often referred to as area composite problems. I like to think of these types of problems as inside-out problems with a twist. Let's delve into one such problem, the kind you might encounter on the GKT test. When you first see these problems, you might feel overwhelmed by all the elements involved. In this case, we know the problem presents a rectangular area, and we need to find the cost in dollars. However, note that the cost is calculated in square yards, but the dimensions provided are in feet. This means our first step is to convert our measurements from feet to yards, making the calculations much easier. For instance, if one side of the rectangle is 60 feet, converting to yards gives us 20 yards, since 60 divided by 3 is 20. Similarly, converting the other side from 30 feet results in 10 yards. Now we're dealing with consistent units, making it straightforward to proceed. To find the area of a rectangle, we multiply the length by the width, which in this simplified example is 20 yards by 10 yards, equaling 200 square yards. We have now found the area of the first and the smallest rectangle to be 200 square yards. But remember, there's a walkway extending around the smallest rectangle, adding 3 feet or 1 yard to each side. So the overall dimensions of the larger rectangle encompassing the walkway becomes 22 yards by 12 yards, calculating to 264 square yards. Now, to find the area of just the walkway, subtract the area of the smaller rectangle, 200 square yards, from the larger rectangle, 264 square yards, which results in 64 square yards of walkway. Finally, to find the cost, multiply the area of the walkway by the price per square yard. With the cost being $15 per square yard, the calculation is 64 square yards times $15, resulting in a total of $960. If we write these numbers as fractions with units, we can see how the units cancel out, leaving us with an answer in dollars.